Two protocols, two tech giants. One question that's going to shape how every AI agent on the planet talks to the outside world. In November 2024, Anthropic dropped MCP. 6 months later, it had become the standard. OpenAI adopted it, Google said they'd support it, thousands of developers built integrations. Then in April 2025, Google announced A2A with 50 partners already signed up. Salesforce, MongoDB, SAP, PayPal, and they did something interesting. They said A2A complements MCP, not competes, complements. But the internet wasn't buying it. Solomon Hykes, the creator of Docker, tweeted, "In theory, they can coexist. In practice, I foresee a tug of war." So what's actually going on? Is Google playing nice, or did they just fire the first shot in an AI protocol war? Let's break it down. You are a developer, you have built an AI assistant for your company. It's smart, it's helpful, but it's also completely blind. It doesn't know what's in your Slack, it can't see your Google Drive, it has no idea what's in your database or your CRM or your GitHub repos. Every time a user asks about something company specific, the AI just guesses or apologizes. So you start building integrations. You write code to connect your AI to Slack, then Google Drive, then Salesforce, then your internal wiki. Each integration takes weeks. Each one has its own authentication flow, its own data format, its own error handling. Think about what USB did for hardware. Before USB, every device had its own proprietary cable. Your printer, your keyboard, your camera, your phone, all different connectors. USB said, "Here is one standard plug. Build to this and everything works with everything." And that's the promise of MCP, the USB-C port for AI. Say you want Cloud to access your company's PostgreSQL database. Without MCP, you're writing custom code. Database connectors, query builders, result formatters, error handlers. With MCP, you spin up an MCP server, which is basically a lightweight wrapper that exposes your database through a standard interface. The MCP server publishes three things. First, resources. These are data the AI can read. Your database tables, your schemas, maybe some sample queries. Second, prompts. Templates that help the AI interact with your data effectively. And third, tools. Functions the AI can actually call. Run this query, insert this record, update this row. Any MCP compatible AI can now access your database. And any MCP server you add to your setup, say for Slack or GitHub, automatically becomes available to all your AI applications. And this is why MCP exploded. Within months of launch, the community had built MCP servers for Google Drive, Slack, GitHub, Notion, Postgres, Stripe, and hundreds more. MCP was the standard. So why would Google launch something different? Google's argument is that MCP solves only half the problem. It handles what they call vertical integration, connecting an AI to the tools and data beneath it. But what about horizontal integration? What happens when you have multiple AI agents that need to work together? Let me give you a scenario that makes this concrete. You are an enterprise. You have got a customer service AI that handles support tickets. You have got a separate AI that manages your knowledge base. A third one handles billing questions. A fourth does technical troubleshooting. Each of these agents is good at its specialty and uses MCP to connect to its relevant tools. A customer writes in, "I was charged twice for my subscription and now I can't log into my account." This ticket touches billing, authentication, and possibly technical issues. No single agent can handle it. The customer service agent needs to ask the billing agent to check for duplicate charges. If there is an account issue, it needs to loop in the authentication agent. If there is a bug, maybe the technical agent needs to investigate. How do these agents coordinate? How does this customer service agent know what the billing agent can do? And how they pass context back and forth? How do they handle a resolution process that might take hours or days with a customer checking in periodically? MCP doesn't have answer for this. It's designed for agent-to-tool communication, not agent-to-agent collaboration. And that's the gap A2A fills. A2A introduces some concepts that are genuinely clever. The first is the agent card. Every A2A compatible agent publishes a JSON file at a well-known URL. Typically /.wellknown/agent.json. This card describes everything another agent needs to know. What skills does the agent have? What authentication does it require? What kind of task it can handle, and how should you communicate with it? Think of it like a LinkedIn profile for AI agents. When agents need to collaborate, they first discover each other by reading these cards. The customer service agent finds a billing agent's card, sees that it can handle refund requests, and now knows exactly how to ask for help. The second concept is the task lifecycle. When one agent asks another to do something, that request becomes a task with a unique ID. And unlike a simple API call, this task has states: submitted, working, input required, completed, failed. The task can take minutes or weeks. Agents can check in on progress. They can provide additional information when needed. They can handle interruptions and resumptions. This matters because real-world business processes aren't instantaneous. That duplicate billing issue, maybe it requires a human in finance to approve the refund. Maybe it needs an investigation that takes a few days. A2A is designed for this kind of long-running multi-step collaboration. Google has also built A2A with enterprise security from day one. Agent cards specify authentication requirements. The protocol supports OAuth, API keys, and can integrate with existing identity providers. This wasn't an afterthought. It was a core design principle. Now, Google has this analogy they use, and I actually think it's pretty good, so let me extend it. Imagine an auto repair shop run entirely by AI agents. You have got a shop manager who talks to customer, you have got mechanic agents who do the actual repairs, and you have got supplier agents who provide parts. When a customer walks in and says, "Hey, my car is making a weird rattling noise," that's an A2A conversation. The manager needs to ask follow-up questions, maybe request a video of the noise, understand when it happens. This is conversational, fuzzy, multi-turn. The manager figures out it's probably a suspension issue and hands it to the mechanic agent. That's another A2A interaction. Task assignment between agents. Now the mechanic needs to actually diagnose the car. They use a diagnostic scanner. That's an MCP tool call. They check the repair manual database. Another MCP call. They raise the lift to inspect underneath. MCP again. These are structured, precise interactions with specific tools. The mechanic discovers a worn bushing and needs to order a part. Now they are talking to the supplier agent. Back to A2A. Do you have the part in stock? When can you deliver? What's the price? This might involve negotiation, back orders, and alternative parts. The distinction is clear. MCP is how agents use tools. A2A is how agents talk to each other. One is structured and synchronous. The other is conversational and potentially asynchronous. But here is where it gets complicated. What happens when the line between tools and agent blurs? Think about a modern search engine with AI capabilities. Is that a tool or an agent? It takes natural language queries, reasons about intent, synthesizes answers from multiple sources, can handle follow-up questions. It has agent-like properties, but it's also something other agents invoke to get information. Or consider a code review system. It analyzes pull requests, explains its reasoning, responds to developer questions, can be asked to focus on specific concerns. Tool or agent? The honest answer is it's both, depending on how you are using it. And this is where the complementary framing starts to feel less clean. If the same system can be both a tool and an agent, what protocol do you use? Do you implement both? Do you translate between them? Developers are already feeling this tension. Building for one protocol takes significant investment. Building for two takes more than twice as long because you are maintaining two integration patterns, two auth flows, two ways of thinking about your system. In practice, teams pick one and optimize for it. AI agents are getting powerful very fast. They can read GitHub PRs, post messages to Slack, create issues, query databases, even send emails. Most of these agents work perfectly on your laptop, but completely fall apart the moment you try to deploy them for a team. And the reason is not AI, it's authentication. You probably know that MCP or Model Context Protocol is Anthropic's open standard for connecting AI systems to external tools like GitHub, Slack, Gmail, and databases. Instead of writing custom integrations for every service, MCP gives you a standardized way to expose tools that any AI agent can call. So when your MCP server talks to GitHub, it uses your token. When it posts to Slack, it posts as you. That works fine for demos, But the moment you want to deploy this for a team, you hit a wall. You cannot hardcode your GitHub token, you cannot share Slack credentials, and you cannot safely run an automation that acts on behalf of multiple users without knowing who authorized what. This is exactly the problem the sponsor of this segment, Arcade, solves. Instead of your MCP server owing credentials, Arcade manages OAuth for each user. Your MCP server never stores secrets. It simply requests actions, and Arcade executes them securely. And this is not a workaround. In fact, Arcade directly contributed to the MCP specification that enables secure tool-level authorization in MCP. And to make this concrete, we built a real automation using Arcade MCP. Whenever someone opens a pull request in a GitHub repository, a notification is automatically sent to a Slack channel with full PR details. At a high level, the system looks like this. A pull request is opened on GitHub. GitHub Actions triggers a workflow. The workflow runs a Python script. That script talks to Arcade MCP. Arcade securely calls GitHub to fetch PR details and Slack to send the message. No tokens are hard-coded, no credentials are leaked. Everything runs with scoped, pre-authorized access. And this is the difference between a demo and a production system. We defined two core files. First, Slack notify YAML. Its job is simple. Trigger on every pull request. All you need to do is set up Python, install Arcade Py, and run the trigger script. This workflow contains no credentials. It only provides execution context. This script uses two Arcade MCP tools, github.getPullRequest and slack.sendMessage. First, it fetches PR details from GitHub, then it formats a structured Slack message, and finally, it sends that message to the configured Slack channel. Everything flows through Arcade's MCP layer. Once GitHub and Slack are authorized in Arcade, this runs automatically on every PR. Huge thanks to Arcade for sponsoring this project and supporting real-world MCP workflows. All links and the full project repository are in the description. Building an MCP server locally is easy. Running it for a team is where reality hits. Now you need SSO, audit logs, token refresh, multi-tenancy. MCP is still evolving on auth. A2A is stronger there, but has a smaller ecosystem. The simple takeaway is, use MCP today for tool integration. Learn A2A for multi-agent setups. And expect real systems to use both. Both will likely converge as tools and agents blur together. And if this was useful, do subscribe and I'll see you in the next one.